Hello, everybody. We are the Foam Buddy team, sponsored by Knox Tech. These are all of our faces and names, and we look forward to showing you what we have in this video. The problem currently is two-component foam spraying applications are usually big rigs, inside box trucks. It costs a lot of money to have people out um, to subcontract to insulate homes. And there's not very many solutions for portable, um, small scale, low pressure two component foam systems. So the scope of this project is to build a low pressure foam dispensing system that moves two material components from 5-gallon pails into the Knox hose assembly. There have been some prototypes in the past. We were tasked with improving upon these prototypes for ease of assembly, ease of maintenance, ease of use, and of course, cost and portability as well. And the other part of the scope is that it must be compatible with the Knox hose and gun that's already made. Some of the key specifications are that the machine must have an adjustable output ratio, because most of the time we're looking for a 1-to-1 output. And there are many little different factors like temperature and pressure and things that may change those. So having a variable output is very important. We are aiming for a volumetric output of 0.25 to 0.65 gallons per minute per side. We are looking for a weight of less than 50 pounds total, cost less than $2,000, and powered by 18 to 24 volt rechargeable tool battery. The device must last the duration of emptying two 5-gallon pails using that tool battery, and each line must have pressure sensing feedback to shut off the motors at a defined pressure set point.
So this is our final design. We have the CAD on the right and then the picture of our finished design on the left. And our device sits on top of the 5-gallon bucket and uses clamps to secure it. It also includes a handle that allows the user to pick up the device and bucket assembly together to move to different locations. And it has multiple sub-assemblies, which we'll go through, which allow it to move material with adjustable output, be mechanically safe, and keep moist air from entering the bucket. So this is kind of the main portion of our design. It's the base plate sub-assembly. So the base plate sits on top of the bucket. It's just aluminum, and it houses the motor and the pump. So we chose our motor, which is a 24 volt DC motor, due to its availability, torque, and low cost. And then we chose a concentric hydraulic gear pump, chosen due to its durability. It has Viton seals, which are compatible with the material, and the pump head that it provides. We also have a motor and pump coupler, and then rubber and feet that sit in the bucket inset for stability. Our clamp subassembly is what actually holds the base plate to the bucket. So we purchased and modified these clamps to be a single piece. We have an angle bracket that connects it to the base plate, and the clamps hook underneath the bucket lip. This is our mechanical cover subassembly. It helps protect the user from moving components and provides a platform for the handle. And then it also houses the battery control box and motor controller for easy disassembly. This is our dip tube holder subassembly. So this attaches to the Reiki spout on the bucket. It's a 3D printed piece out of polypropylene, and it holds the dip tube in the center and creates an airtight seal so that only air can enter through the desiccant, which allows no moist air to get into the bucket. And finally, this is our plumbing assembly, so what that material actually moves through. It includes a hose that goes to a ball valve and then to the pump. And then on the other side, we have a check valve to keep material from backflowing. We also have a pressure switch to tell the motor when to turn off if the pressure gets too high. And we have our pressure gauge to communicate the state of pressure to the user. And then finally, on the other side, we have the connection to the Knox hose.
So here is our electrical control box. You can see on the right, the inside, and the left is what the user would see on a regular basis. You have your on and off toggle switch. This is what will actually give power to the motor or not, depending if the potentiometer is turned, which the potentiometer actually will give you your ratio control. It'll speed the motor either up or down, depending on which way you turn it. This is really good for improving our ratios, getting that adjustable ratio, same as well as when you're about to spray foam for the first time, you have to do that ratio check. On the right image, you can see the inside of it. It's overall pretty simple. You have your two bus bars for your positive and negative voltage. You have the toggle switch on the top, which is just feeds off of the motor. And then at the bottom, you have the relay, which feeds the positive side of the motor, and then, provides the positive side of the motor, which is triggered by the pressure switch output. Some prototyping and obstacles that we've encountered. So our first prototype actually included a set of connecting wires with one battery overall. The problem with this, however, was since the pressure switches were in series, this is a digital pressure switch we used compared to a mechanical one. And the design of it it shares a common VCC, a common and VCC. So when the power on the A side was cut off, it would completely shut off the B side. So when you pull the trigger, it would take a second to one turn on and then re-engage that pressure. So there was some dipping in it, which you can see in the middle row on the left-hand picture, how one stream is significantly less than the other stream. But this was eliminated, however, by doing the dual battery design. We also tested our clamps, which is the middle image on the middle row, multiple revisions of that, as well as some stability testing with a fishhook on the far right image. And then a lot of revisions that we did for testing were the bucket connector with the dip tube. You can see all of the revisions on that bottom image here, starting from the left one, which was the oldest, to the final design, which is the far right.
Some final design testing that we did was checking that the output ratio could achieve a 1-to-1 ratio, and that is shown in the top left photo with the two cups. We took off the nozzle and sprayed it into the cups, and they're at the same level. And then we tested the volumetric output to show that it can output 0.25 to 0.65 gallons per minute per side, and that's shown in the gallon picture on the bottom left. And as explained before, we were having some issues with the lag in the nozzle spraying, and so we tested that again to ensure that the spraying was instantaneous as soon as you pulled the trigger, and that's shown in the right picture. And then we tested the weight of the device to ensure that it fits our specifications, and the final weight was shown to be 23.7 pounds. And then now we will show a project demonstration video as well as a video of us spraying the device.
Welcome to the Foam Buddy tutorial on how to set it up. You got your 5-gallon pail of material. If you're running 2 component systems, you'll have 2 of these, but it's the same procedure for both. Over here you got your actual Foam Buddy machine, all set to go with your dip tube over here and the hose that connects to it, along with the bucket connector and your desiccant. So we will start by placing the Foam Buddy up on the bucket, making sure to pay attention that the spout on the bucket is in the center of the slot. From there, you'll come over to the clamps, and you can adjust them up and down just by spinning it, and you'll attach it onto the bucket and flip it up like that, and do the same for the other side as well. Then you'll take your bucket connector, twist it on to the spout on the lid. And you take the top part with your desiccant and snap it in, just like that. And then you'll take your dip tube, slide it right down in, just like so. And then take your pickup tube, place it right on there, and tighten it down. From there, just make sure that your ball valve is open, Place the battery inside the battery connector and flip the switch to on and set your speed using the potentiometer. Over here you have the hose side. This is where your hose will connect to. So you'll have a hose similar to this. One side will connect here. You'll have your B side component over here and connect the other side of the hose to that, and you'll be good to go.